When we talk about the 1940s, especially the home front experience, we tend to focus on rationing, victory gardens, scrap drives, and industrial output. But we rarely talk about the single domestic issue that dominated winter heating. Coal shipments were inconsistent, electricity failures were common in both cities and rural districts, and furnaces were unreliable, especially the early automatic feed models. Yet families still kept their homes warm even in brutal winters. What kept everything running wasn't magic, and it wasn't a miracle design. It was an ingenious hack that homeowners used to turn a simple radiator into a whole-house convection engine. It required zero electricity, zero motors, and zero modern materials. And when people test it today, they're shocked to see that it can outperform the efficiency of many modern forced air systems simply because it uses physics instead of power. If you've ever wondered how households heated multi-room homes before blowers, fans, thermostats, or even consistent coal delivery, that's exactly what we're uncovering today. This is a practical system you can replicate in a modern home using scrap materials. And if you're a survivalist or historian of domestic technology, you'll appreciate how every detail lines up with the engineering logic of the period. Let's get into the historical technique itself. How 1940s households turned a passive radiator into an active heat pump using only airflow mechanics. A cast-iron hot water radiator gives off heat in two ways: radiant energy from the iron and convection as hot air rises off its surface. But the standard setup wastes tremendous potential. Most heat collects near the ceiling, leaving the rest of the house cold unless you have circulation from a fan or blower. People in the 1940s didn't have that luxury during outages, so the hack they developed was simple. They forced the radiator to channel all rising heat into a controlled airflow. Instead of letting warm air rise randomly, they created a draft column using a metal or wood shroud placed over and behind the radiator. The shroud acted like a chimney, accelerating the movement of warm air upward and out into the room. When paired with a floor-level cold air intake, the system turned the radiator into a self-powered convection engine. This wasn't a niche trick. Builders documented it in mid-century carpentry manuals, especially for homes where only one or two radiators served multiple rooms. You'd find sheet metal shrouds in row homes, brownstones, and farmhouses. They were cheap, widely understood, and honestly, brutally effective. Try this today. Take a sheet of thin metal roofing, bend it into an L shape, and position it behind your radiator so it directs rising air straight upward instead of allowing dispersion against the wall. Within minutes you'll feel the difference as heat moves through the entire room. How the shroud and channel system heated entire homes without electricity. The real innovation wasn't simply covering the radiator. The 1940s method added a second step, connecting that rising warm air column to a ceiling or transom opening leading into the next room. Many older homes were designed with small vents above door frames for this exact reason. These were never decorative. They were heat transfer portals. Once the radiator created a strong upward draft, heat naturally migrated through these high vents. Because warm air always seeks escape, homeowners could direct it strategically. Bedrooms on upper levels received rising heat, while kitchens and parlours on the main floor received horizontal flow through transoms. In other words, each radiator didn't heat just one room. It heated whichever part of the home was connected through that airflow network. To apply this today, especially if you live in an older house, if you have a tall doorway or unused transom frame, simply open it during winter and place your radiator shroud beneath. You're recreating the original heat highway that older architects intentionally designed into the home. How reflective panels doubled a radiator's output without using extra fuel. Another forgotten component of the hack involved reflectivity. Homeowners realized that a radiator placed against an exterior wall lost heat outward. To fix this, they installed a reflective sheet, first tin, later aluminum, between the radiator and the wall. This didn't merely bounce radiant heat back into the room, it also prevented thermal loss through poorly insulated walls. The results were dramatic. Tests done by municipal fuel boards during the war showed that simply adding a reflective backing panel reduced fuel consumption by up to 20% in cold regions. People didn't call it energy efficiency back then. They just called it common sense. Today, a modern equivalent is even easier. Take a reflective emergency blanket, mount it flat onto a piece of cardboard or thin plywood, and stand it behind your radiator. You'll notice the wall behind it stays cool, exactly what you want, while more heat pushes outward into the room. The 1940s hack became even more effective in multi-story houses. Homeowners deliberately used staircases as heat conduits. A radiator on the main floor, shrouded and directed upward, could heat the upper floor by channeling air into the staircase opening. Some families installed removable wooden louvers or curtain-style heat gates to manage the airflow and keep it circulating instead of dissipating. So, here's a simple modern version. Just place your shrouded radiator near the base of a stairwell and, keep the path above it completely unobstructed. Warm air will naturally climb the staircase all on its own. If you're after even more efficiency, simply close off any unused rooms upstairs so the rising heat concentrates precisely where you want it. Now, if you're serious about testing this historically accurate technique, here's the process as a complete method. Step 1. Build or buy a simple radiator shroud. Metal is ideal, but plywood works in a pinch. It must open at the bottom and at the top to permit proper airflow. Step 2. Place a reflective backing between the radiator and the wall. Step 3. Identify your vertical airflow targets. These might be staircases, transoms, open doorways, or ceiling vents. Step 4. Create a clear pathway for heat to move. Remove barriers, open those interior doors, and, keep furniture out of the airflow column. Step 5. Allow the convection engine to run continuously. The longer it operates, the more stable your home's internal temperature becomes. This is a survival-grade system. You can run it during a blackout. You can run it with minimal fuel. And honestly, you can run it indefinitely without damaging the radiator. The strength of this hack isn't nostalgia, it's engineering. People in the 1940s faced energy challenges we rarely appreciate today, and they solved them using physics, not electronics. They understood airflow, reflection, insulation, and thermal movement far better than most homeowners do now. And because their methods required no electricity, they remain valuable in blackouts, off-grid cabins, or any winter emergency. If you value historical knowledge that actually works, knowledge you can test in your own home, this technique truly deserves a place in your toolkit. If you learned something new here, remember to subscribe, share this video, and help the channel keep digging up the forgotten practical history the textbooks leave out.